Alright guys, so as mentioned, this will be the answer key to the rice, coffee, beans worksheet that I assigned in class today. Um, and so I'll just go through each of the questions, and if anyone has any questions, they can email me. So the first part is regarding the correlation coefficients and the um, hypothesis test associated with it. And so first we're going to go ahead and do our correlations. So parts A, B, and C, I'm asking you to correlate rice, beef, and coffee with each other. So we're going to first ignore time, which is column A, and do these three with each other. And so let me just move this down a little bit. Okay. So we're going to do rice and beef, rice and coffee, and then rice and, beef and coffee. So just as a review, to find a correlation coefficient, we can use Correl. For Correl, the order doesn't matter as much. If I put CCBB and I put Correl BBCC, I'm gonna get the same numbers. As a habit, it's good to be thinking about which ones are more independent variables and which ones are more dependent variables, because for the other functions such as line of best fit with slope, intercept, those will matter. Rice, coffee, Correl, I'm gonna do coffee to rice, so coffee to rice, and I'm gonna do beef, coffee to beef, so DDCC. Yep. Yeah. Oh, hang on, I did this wrong. This is supposed to be BBCC, and this is and D. There we go. Okay. There we go. And so for my first two answers, so part A, the variables with the highest correlation is rice and coffee. That's at 0.45. So rice and coffee at R equals to 0.45. And the least correlation is between beef and coffee. Beef and coffee at R is equal to 0.14. 114. I'm just gonna round to 2 decimals. That's okay. All right. So for this next part, we will be dealing with the if the correlations are significant. Whenever you see the word significant, that basically means that I want you to perform a hypothesis test. In this case, I don't have the words positive or negative, and so this will be a two-tailed test. So let's go ahead and do that. So first I'm gonna find my t value, my critical value. You can do this using your t table. If you use your t table, I believe you'll get 2.62. If you do it through Google Sheets, since we're using two-tailed, 0.01 with degrees of freedom being the amount of data minus 2. So you'll get 2.59. Really quickly up here, this is my amount of data. And so now we can use our formula, right? Which is t is equal to the r over the square root of 1 minus r squared over n minus 2, or the degree of freedom. So this will be the formula, and our r is going to be up here. So the thing about this is that all of them are going to be using the same graph. So you can just draw one graph and plot 3 dots on it. I can't really, I'll show you in a second. But first let us do these numbers. So I'm gonna go ahead and just use Google Sheets for this. I would generally suggest using a calculator because that is what most of you are going to be used to. But I'm just gonna use Google Sheets. So 0.22 actually. So this number divided by the square root of 1 minus this number squared divided by this number up here minus 2. And so that'll give me 4.18. I'm going to just drag this and have it. Right. Hang on. I don't want this number to change. So now I can drag that. Okay. So I now have my 3 numbers along with my critical value. Let me put this in blue. And so let's look at what that looks like on a graph. Switch over to, let me switch over. Okay. And so let us draw my curve along with my 2 lines. So these are the rejection regions, and I have my critical values at negative 2.59 and 2.59. So my dots, you can't see them right now, but they're at 4.18. So rice and beef is over here. This is rice and beef. Rice and coffee is at 9.36. So all the way over here is rice and coffee. And then beef and coffee is at 2.13. So that's in here is beef and coffee. And so we have 2 dots that are in the rejection region and one that is in that we failed to reject HO. So let's switch back. Okay. So for these, I reject HO here. This one is also reject HO. And this one we failed to reject HO. And so what this means, whenever we, for correlation for hypothesis testing, whenever we reject HO, that implies that there is a significant correlation. So these have significant correlation. I'm just going to say significant core. This one also has significant core. And this one, no significant correlation. On your answers, from now on, if I ask you to just say which ones have correlation with each other, what I need is the graph along with your however many dots you need to plot, and then just say which ones have correlation or not correlation. This part with the reject or not reject, I'm less concerned about, although it will give you partial credit if you messed up the wording. So here we can say that rice and beef, rice and coffee have significant correlations. And then we have beef and coffee do not have significant correlation. And so with that, this first part is done. The second part, I want you to be able to correlate variables with time. So we will be doing the exact same thing, except instead of with each other, I will be doing each of them with time. So again, oops, sorry about that. Let me move this out of the way a little bit. So we're gonna do time and rice, time and coffee, time and beef, and then time and coffee. So equals Corel, and Yeah, so here time is independent, right? Even though it doesn't matter much, um, in this scenario, both ways will give you the same numbers. Uh, it's always good to be in the habit of putting time as our independent variable. So here we can have BBAA. Here we're gonna have CCAA, oh, Corel CCAA, and then Corel DDAA. And so I have my correlation coefficients. Since I already did the formula here, I can just copy and paste that a little bit and change this from F8. I want that to be F6, I believe. F10. Um, and F10 here. Okay. And so I have my, for the next part, for part D, I'm just going to look at these. Okay, so my highest correlation, highest is time and beef. My lowest correlation is time and coffee at R is equal to negative 0.04. For the highest, it's R is equal to 0.601 or 61. Sorry about that. Hypothesis testing, we're going to do the same thing. From here, I'm not going to graph it. I'll let you try doing that yourself. But time and beef is very obviously going to be reject HO. Reject HO. The other two, we're going to fail to reject. Fail to reject. An easy way to look at it is we know that these two are going to be between negative 2.59 and positive 2.59, right? And so we will fail to reject these two, which means that the only variable that has a significant correlation with time is beef. The other two do not have significant correlation. No significant correlation. Again, I'm just going to repeat that into my data here. Oh. Significant time and beef. Not significant is time and rice or time and coffee. And that is really all I would need you to be able to do for these first part. The reason why I'm giving you a lot of hypothesis testing questions is because if you're able to do it quickly, it should not take that much time. A lot of times I'm just going to be giving you the exact same graph and you just have to put more dots into it. The hardest part is keeping track of which dots are which variables. So just make sure that you're able to have a way to label those. Right, so part two, with line of best fits and predictions. Scroll up a little bit. Okay. So my first question is about making an equation for any variables that have significant correlation with time. And so anytime I say write an equation, that is essentially I want you to write y hat. If I can, nope, I can't. Okay, so it should be y hat is equal to mx plus b, right? That is the equation that we are going to use. And so that's all you have to write. All you have to figure out is the slope and the intercept. So part two, question A, the only variable that has significant correlation with time is beef, right? We figured that out from this number here. And so beef and time, to find the slope, we use equal slope. Dependent is our beef price and independent is our month. Do the same thing but use intercept. So beef and month. And that should give me my slope and intercept. And so in my equation here, I'm going to write y hat is equal to 0.005x plus 3.1. 3.11, 3.10. I'm okay with both. B, I want you to write the line of best fit between rice and beef using beef as the independent variable. So rice and beef are columns B and C, so equal slope. Beef is independent, so dependent is rice, beef equals intercept of rice and beef. Again, all I need to write for my equation is y hat is equal to 0.33x plus 0.34. And that's it. That's all I really need you to be able to write and figure out the slope and y-intercepts. Next up, the next three are predictions. Predictions, you can either find a line between the two variables and then find the answer. Alternatively, you can use the function forecast. So forecast is basically predicting something. So here I want you to predict the value of beef if the price of rice is 0.84 kilos. And up here, this is important. Assume that any given value is the independent variable. And so my given value is 0.84. That is rice. And so rice is independent. That means that the dependent variable is beef. So beef, rice. And so when rice is $0.84 per kilo, the price of beef is about 0.58 dollars. So dollars, $4.58. A way you can double check this if this feels off is to insert a scatter plot. Let me insert a scatter plot, and I'm going to have a line, trend line. And let me make sure that this line is visible. Let's use red. Make it a bit thicker. Okay. And so here, my where my rice is going to be 0.84, it's going to be about right here. If I draw a line up to this line, it's about 4.5. So I can know that this is correct. That what I did there with my forecast gave me an approximately correct answer. I'm going to skip D for now. E is the same thing. We're going to use the price of coffee to predict the price of rice. So forecast using coffee, which is 7.1. So coffee is my independent, rice is my dependent, so BBDD. So the price of rice when coffee is $7 is about 60 cents per kilo, 61 cents per kilo. Finally, the price of beef in August of 2023. So the key thing here is that these numbers are months since 1992. What this means is that in January of 1992, that's month number 1. February of 1992, that is month number 2. All the way down to December 1992, that'll be month number 12. And so our first task is figuring out August of 2023, what is that month number? And so we can kind of use logic to kind of go through this. December of 1993 is going to be month 24. December of 1994 is going to be month 36, right? It's going up by 12. And so from 1992 to 2000 December 2022 is going to be how many years, right? And so this is about 30 years. right? From 1992 to December 20. So 30 years times 12 months. So December 2022 is 360 months. January, sorry, did I do that right? Yes. So January of 2023 is going to be month 361. August is going to be month 368. And so we can now use forecast to get month 368. We want to find the price of beef, so CC, using time, AA. So the price of beef will be about $5.01. And that is pretty much everything I need you to be able to do. That last one is probably more difficult than what is going to be on the test when talking about I have to find the date, the number of months first, and then use that. Um, that that type of question will more likely be in along the lines of a bonus question, but you do need to be able to figure out, okay, this many days I need to plug this in for X or forecast it, and which columns go where. Um, the goal is this is essentially the first half of the test. And so if you're able to do this within the first period, the test is going to be 2 days. If you can do this within the first 50 minutes that we have class, then you're pretty much on good track to finish the test on time. And so that is kind of the goal of this mid chapter, is if you are confident that you can do this in 45-50 minutes, then you're on track to finish the test on time. Otherwise, you can figure out where you need some extra work. The bonus, I will kind of let you try that on your own. I'll answer the first two questions. So coffee does not have significant correlation with time, as you can see there on the right. So no, coffee does not. The only one that has significant correlation with time is beef, right? And so the path to get from time to coffee using only significant correlations, we're gonna need to do a little bit of a runaround, right? And this should be coffee, not aluminum. And so essentially, we're gonna have to go from time, predicting time, to beef, which we've already done in D. From beef, we can't go directly from beef to coffee because there's no significant correlation there, right? You can see here, beef and coffee do not have any significant correlation. And so from beef, we need to take a detour to convert beef to rice, and then we can go convert from rice to coffee. So this, if you do figure out the answer to this, you can write it down, hand it to me in class, and I'll let you know if you got it right or wrong. But that's essentially kind of the idea of the bonus question, is that you're gonna need to do a few more steps. And so that is pretty much everything for this data set. Again, this is preparation for the test, making sure that you know what you are supposed to be able to do on Google Sheets. And if you can do these things, then you will be pretty much set for the first half. For the second half, since there's a lot of online students going on right now, I will be making videos for the next 2 to 3 lessons about what you need to be able to do on Google Sheets. And I will upload those daily or as the week goes. So if you have any questions, you can email me, let me know in class, and I'll try to get back to you as soon as possible. That's it. Yeah. Let me know if you have any questions.